Trig homework 4 starts off here with simplifying a radical expression with two variables. And so here again we want to simplify. We want to look first of all to see if we have perfect squares. If they're not perfect squares, we need to factor them. If it has an even exponent, it is a perfect square. If it has an odd exponent, it's not a perfect square. In order to make it a perfect square, we're going to factor out one of the variables. So if I'm going to simplify this one, I'm going to rewrite this. 50, not a perfect square, but I can factor it into 25 times 2, 25 being the biggest perfect square that divides into 50. S to the 12th is a perfect square because it does have an even exponent, but t to the 11th is not. So I'm going to take out one of my t's and make it t times t to the 10th power, so that I do have an even exponent. So I always just take out 1 if that's odd. I'm now going to take out my perfect squares. Square root of 25 is 5. 2 is not a perfect square. Square root of s to the 12th, half of my exponent, so x to the 6th. T is not a perfect square, but t to the 10th is. Square root of t to the 10th would be t to the 5th. Again, half of my exponent. What I have left underneath is a 2 and a t. So my answer, 5s to the 6th, t to the 5th, square root of 2t. So number 32, same kind of thing. Now in this case, 36 is a perfect square. So I'm going to leave 36 alone. I'm not going to factor it out. X to the 9th is not a perfect square. I'm going to factor out one of my x's and make it x times x to the 8th. Y to the 3rd is not a perfect square because it has an odd exponent. I'm going to factor one of them out and make it y times y squared. So taking out my perfect squares, the square root of 36 is 6. X isn't a perfect square. Square root of x to the 8th. X to the 4th, half of my exponent. Y isn't a perfect square, but y squared is. Square root of y squared. Plain old y to the 1st power, so just y. What I have left underneath, the x and the y. So 6x to the 4th y, square root of xy would be my answer. Sneak this one in here. Hopefully you can see down there on the bottom of the board. 48. 48 is not a perfect square. I want the biggest perfect square that divides evenly into 48. So in this case, 16 times 3. Although 4 goes into 48, it's not the biggest one, so 16 is my better choice to get it simplified and completely reduced down. X to the 11th. I'm going to make that x times x to the 10th. Since it has an odd exponent, y squared. Just going to leave that one alone. It already has an even exponent. So taking my square roots, my perfect square roots out, I can take out the square root of 16, which is 4. I can take out the square root of x to the 10th, which is x to the 5th. I can take out the square root of the y squared, which is the y. What I have left underneath is a 3x. So 4x to the 5th y, square root of 3x would be my answer.